All right, so today we're going to talk about the exponential decay equation, and we should notice that it's exactly like the exponential growth equation. The only thing that's different is it's 1 minus the rate. So this is what our decay graphs look like from yesterday. They were decreasing, which means they represent our decay function. Decreasing, DEC, and then decay starts with DEC as well. So that's a good way to remember that decay means to be decreasing. So we're going to label each one of the parts of the equation. They're exactly the same as our growth equation. So our A is still the amount. This is our total amount. Our P, that is our initial amount or our starting amount. Our R, that represents the rate, and remember we have to do the percent divided by 100. That's how we get our decimal decay rate. And then T is still representing time. So that is usually years. Sometimes it's measured in other ways. So go ahead and get, all right, so Janet purchased a new car for $25,000. The moment she drove it off the lot, it began depreciating, which means decreasing, 15% per year. So I'm going to highlight a couple of different things. So we started out, we bought the car for $25,000 and it's decreasing at 15% per year. Why is it not letting me highlight just that 15? There we go. All right, so we're going to use our formula. So A is equal to P, 1 minus the rate to the T power. And then we want to know what it's going to be worth after 4 years. So we have A is equal to, our initial amount is $25,000. 1 minus, so 15 divided by 100. What do I get when I do 15 divided by 100? 0.15. So that's what I'm going to substitute into my equation. And then T is equal to 4, because we want to know how much it's going to be worth after 4 years. So we're going to type this into Desmos. This is what it looks like when you type it in, 25,000, parentheses 1 minus 0.15 to the 4th power. So we're talking about money, so we only need to go over to that second number. So this 6 is going to round this 5 up. So this is going to be $13,050.16. So the total amount, A, is equal to $13,050.16. That's the total that the car is going to be worth after 4 years. So if you buy a car, when you go to sell it, you're going to be selling it for less than what it bought it for, typically. All right, so the last example says you take 325 milligrams of ibuprofen. So that's how much you start with. During each hour, the amount of medicine in your bloodstream decreases by 20% each hour. Write an exponential equation giving the amount of ibuprofen in your bloodstream T hours after the initial dose. So we're going to use our formula. A is equal to P, 1 minus the rate to the T power. So we'll figure out what all of our variables represent. So A is equal to 325, because that's how many milligrams I started with. 1 minus, so 29 divided by 100 is going to give us our rate. So when you do 29 divided by 100, you get 0.29. Very good. And then it says how much ibuprofen is going to be in your bloodstream after 3 hours. So that means my time, my t, my exponent is going to be 3. So we'll go ahead and take a moment to type this into Desmos. So 325 times 1 minus 0.29 to the third power. So it looks like we have about 116. We're just going to round it to the nearest whole number. So approximately 116 milligrams of ibuprofen left in your bloodstream after 3 hours. And that should make sense because when you take medicine, the amount of hours that go on, the less medicine is going to be in your bloodstream. And then you're going to have to take more medicine once it all wears off. So this is the notes technically for page 53. So you're also going to just do the same assignment that we did for page 51. We're just going to do the back, the exponential decay examples. So go ahead and get that page 51 assignment out and flip it over onto the back, and we're going to do the decay problems.